Yellowstone Supervolcano vertical inflation and displacement at Hebgen Lake region. It's inflating with magma. It's also moving north on the north coast and south of the south coast. And we're taking a look at the GPS stations showing us the movement and the inflation of magma, and also the update by Mike Poland having to do with what's going on and the earthquakes at Yellowstone. Taking a look at what's happening at the Yellowstone Supervolcano, Wyoming, Idaho, Montana area. In the past week, we've had some pretty big earthquakes, 3.3 at a depth of about 6 miles. And looking at that, this is our area right here, just southwest of Yellowstone Lake, which is on top of the lake, on top of the caldera roof. And we also had some other ones around the, here 3 magnitude, Mammoth, Wyoming, not far from Mammoth Hot Springs. And we know that this area has a lot of earthquakes, as we'll see in the USGS Mike Poland update for Yellowstone. But I want to take a look at the vertical deformation that's taking place in this area. We're going to take a look at a few around Yellowstone Lake and where these earthquakes are more frequent around Mammoth Hot Springs and Hebgen Lake, where we had the 7.3 magnitude earthquake back in August of 1959, which was huge, causing landslides. This is Hebgen Lake, and we notice that it's an opening. Basically, all this is river systems everywhere. Everywhere we have a river, you have a fault line. That's the first thing you learn in Geology 101. Every river is a fault line. So what's happening here? But let's take a look. Here we are. Let's pan out a little bit. You can see this is Yellowstone Lake, and this is Hebgen Lake right here. Let's take a look at some of these GPSs. YPT, last 24 hours. Sorry, that's the seismometer. Where's the GPS? Seismometer. No, let's take this one. HVWY. Okay, so you can see that we have a displacement there. Going up means it's going east. This has been going west, then a little bit east, west, and now it's going east. So you can see it's pretty sort of breathing. This one here, if it goes up, means it's going north. It was going up. And then south, and then north, and then south. So it's now going from northwest. It is now going southeast. And this is the vertical displacement from 2006 up to today. You can see it was increasing, inflating, deflating, inflating, deflating, inflating. So a lot of movement, HVWY, a lot of movement here. But let's take a look at GPS P714. That's pretty steady. And this is Mammoth Hot Springs area right here. That's pretty steady, but let's go here. And let's go in a little bit more so you can see the actual area. Hebgen Lake. GPS P456, which is just north of the lake. Let's see what's happening to that deformation there. What's happening here? It's going up, so it's going east. It's going up, so it's going north. It's going northeast, and it's inflating. It's inflating. This is seasonal activity, increasing in the summer, decreasing in winter, because in the summer the ground is inflating with the water that it picks up. So it's inflating, and it is going, as this shows here, northeast. Let's keep that in mind. So the north area of Hebgen Lake is going northeast, northeast, this way. Oh, let's go see this one for nothing. Okay. Northeast again. But this one, what's happening here? On the south side of the lake, P458, what's happening there? Pretty steady. It's steady, but it's going south. and it's inflating a lot less. So this is going south. This is going south, and this is going northeast. So what's happening to this area is basically opening up. This is going south, as we saw, and this is going northeast, as we saw. Again, what's happening here? Again, this is going south, and it's inflating. Okay? This one here, P676. So this area is going south, and this area is going northeast. So Hebgen Lake has a lot of movement, and it's inflating. And let's go to this one, P361. That's pretty steady, but it's still going south, as we can see. It's still going south. Okay. So we have the areas of Hebgen Lake going south and inflating, and we have the northern part of the Hebgen Lake coast going northeast and inflating. So that's what's happening here. A lot of movement, but they're away from each other in Hebgen Lake. Okay, so please leave your comments. Thank you for your support. Just an update on what's happening on that area of Yellowstone Supervolcano. As we know, it's one of the 21 some odd supervolcanoes of the Earth, and it has 60% of the world's geysers and over 10,000 hydrothermal areas. Let's listen now to Mike Poland's update. Thank you.
Mike Poland, the scientist in charge of the Yellowstone Volcano Observatory. This is a monthly update for August 1st of 2022. Coming to you today from beautiful Mammoth Hot Springs in Yellowstone National Park. Now, I thought over the next few months we might talk about the different types of hot springs that we can see in Yellowstone. There's three different types. There's neutral chloride hot springs. These are the types that we might see around Old Faithful area. There's acid sulfate hot springs, something typified by mud volcano. And then there's travertine hot springs, and that's what we have right here at Mammoth Hot Springs. Now, travertine is sort of a different type of hot spring. It's cooler than we see in the other areas of the park. And the chemistry of the springs here is also different. It's controlled by the subsurface geology. Now, we're outside the caldera here, well north of the caldera. And the rocks beneath us are actually made of shallow marine sediments. This whole area, tens of millions of years ago, used to be a shallow inland sea. And so there are lots of sandstones and slates and even limestones that are composed of the shells of small marine organisms that have accumulated over time in this area and became part of the bedrock geology of the region. Now, it's also a zone of persistent hydrothermal activity and faulting. And so hot fluids from the Yellowstone caldera area can migrate up in this direction. And as those hot waters interact with those marine sediments from that shallow sea that existed tens of millions of years ago, they pick up calcium carbonate, that limestone material that's part of the sediment. And as it rises to the surface and gets to the surface, it drops that calcium carbonate. And so that's how you get these beautiful terraced springs. It's made of calcium carbonate, basically the same thing that we see in marine limestones, but here at the surface deposited as a hot spring material. And we see this sort of hot spring material all throughout the Mammoth Norris area. In fact, even north of the park. There's some hot spring deposits near Jardine or Leduc Hot Springs, and south of Mammoth Hot Springs, Terrace Mountain is one of the oldest hydrothermal areas that's known in the park, about 400,000 years old or so. So travertine is kind of an interesting aspect of Yellowstone's hydrothermal system. Not like the stuff we see in the caldera. There's a few minor travertine springs in the caldera, but really what we see here is pretty unique, all because of the subsurface geology of the region. Okay, now let's talk about what happened in Yellowstone in terms of seismic deformation and geyser activity during the month of July.
Over the past month, we saw normal background levels of activity in the Yellowstone region. The University of Utah Seismograph Station, which is responsible for the operation and maintenance of the Yellowstone Seismic Network, located just 59 earthquakes in the region during the month of July. You can see they're spread sort of throughout the region, but most of the events occurred in this belt between Hebgen Lake in western Montana and Norris Geyser Basin in Yellowstone National Park. This is where most of the seismicity in the Yellowstone area occurs historically. Now, the largest earthquake of the month was a magnitude 3.1 that occurred about 14 miles or so south of Mammoth Hot Springs in Yellowstone National Park. And this was a part of a small sequence of earthquakes, 13 located events that occurred right at the end of the month. So, normal background levels of seismicity in July in Yellowstone. Turning now to ground deformation, this is vertical deformation at the White Lake GPS station, which is located on the east side of Yellowstone Caldera on the Sour Creek Resurgent Dome. This plot spans the past 2 years. Each one of these dots represents a day of data. Downward trends indicate subsidence, the ground going down, and upward trends indicate uplift, the ground's rising. You can see over the last 2 years, and in fact going all the way back to 2015, there's been an overall trend of subsidence. But it is interrupted in summer months by a pause in that subsidence or even a slight amount of uplift. You can see it here during the summer of 2021, and again ongoing right now during the summer of 2022. This is caused by water from snowmelt that percolates slowly into the ground and then causes the ground to sort of puff up, just like a sponge getting wet. And we see this throughout the region. For example, this is GPS data from the west side of the caldera. This is close to Old Faithful on the mounted lake resurgent dome. There's an overall trend over the past 2 years of subsidence, but during summer months, like here in 2021 and happening right now in 2022, that subsidence pauses or even turns around just a little bit due to water that's percolating into the ground and causing it to puff up like a sponge. The overall subsidence rate is only a couple of centimeters a year, about an inch a year, and the amount of uplift that occurs over this time period is less than half an inch. So we're talking very, very small amounts of change. It also is being recorded in the Norris area. This is the GPS station over the last 2 years near Norris Geyser Basin. There's not a whole lot of overall deformation, but again, you can see during the summer months, 2021, and again in 2022, this slight amount of uplift that's caused by groundwater that's percolating into the subsurface. This large signal right here in late 2021 is actually due to snowfall, which covered the antenna and affected the way the GPS signal was being recorded. Now, if we look at the long term, you can see the signal quite clearly. This is back at that White Lake GPS station on the east side of the caldera, and it's since 2016. So vertical deformation overall is showing subsidence of a few centimeters, about an inch or so per year, but every summer, 2016, 2017, 2018, 19, 20, 21, 22, you can see that that subsidence trend is interrupted by a pause or a slight amount of uplift. So this seasonal signal is caused by groundwater that's percolating into the surface from snowmelt and causing the ground to sort of puff up. Finally, turning to Steamboat Geyser, everybody's favorite geyser, the tallest geyser in the world, we actually did not see any major water eruptions during the month of July. Now, this is a plot of the temperature that's being measured in the Steamboat outflow channel. All of this sort of very thick line, lots of up and down motion, is an indication of minor eruptive activity. We typically see a lot of minor activity before the major eruption. And this spans the last 2 months, so you can see a major eruption here on June 10th. Temperature dropped. We saw daily temperature variations, a lot more minor activity leading into a major eruption on June 20th. Then we went back to daily temperature variations. This is basically the geyser being dry. And then starting in sort of early to mid-July, we start to see this minor activity pick up again. So it looks like Steamboat is probably building towards another major water eruption, hopefully sometime in early August. So it looks like Steamboat is not done quite yet. It's not as active as it was in previous years, but still having a lot of minor activity, so hopefully leading to a major eruption soon.
Well, that does it for the Yellowstone update for August 1st of 2022. Now remember, if you have any questions at all, you can feel free to email us anytime. Our email address is ybowebteam, that's all one word, at usgs.gov. And next month, we're going to come to you from another type of hot spring in Yellowstone as we explore these 3 different areas of thermal activity in the park.
Kindly support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.